All right, everybody, hello and welcome back. Today what we're going to do is we're going to continue solving quadratic functions, but we are going to use a different method today, and that is going to be inverse operations. So our steps in solving quadratics are always the same. We first set it equal to 0, which means we're looking for those x-intercepts. We try to factor out a GCF if possible, and then we pick our method. Today, we are going to focus on inverse operations. The reason that we want to do this is sometimes factoring does not work. All right, so we are going to need to have several different methods to apply in order to solve different quadratics. Factoring is great, and some of us are comfortable doing it, some of us are not. So sometimes we are not going to be able to factor to get our solution, and that occurs when our solutions are not nice rational numbers. So what I mean by that is when they're not nice whole numbers or fractions, sometimes we'll get irrational numbers, which we will take a look at here, which requires different methods of solving. So here's our first method. If you take a look at this, many of us will realize this looks quite different than our other quadratics. This is not in standard form. The big takeaway here is there is only one x value. If we go back to the problems we were looking at previously, there's two different ones. There's an x squared and an x. So that's typically your big indicator here that you are going to want to use inverse operations. Inverse operations include undoing all of the values we have on one side to get x by itself. So the first thing we're going to want to do is we're going to want to isolate that x value by moving everything away from it that we can. Now we've got a 2 on the outside, so I'm going to go ahead and divide both sides by 2 first. These will cancel. I'll get x minus 1 squared is equal to 5. Now, I really need to get x alone, which means I need to get inside those parentheses, which means I need to get rid of that exponent of 2. In order to do that, the inverse of an exponent of 2 is going to be a square root. So I'm going to take the square root of both sides. On my left side, I will cancel the exponent of 2, which means I no longer need the parentheses. And then on my right side, I will have the square root of 5. But what we need to remember is when we are taking the square root of a value and we are solving, we need a plus and a minus. My last step here is going to be to add 1 to both sides, and I will get x equals 1 plus or minus the square root of 5. So just like before when we factored, we still have two solutions. We have 1 plus the square root of 5, and then we have 1 minus the square root of 5. We don't need to do this. We could just leave our solutions like this, but remember the square roots of numbers, the square root of 5, it really just gives us values or decimals that aren't necessarily nice numbers, but they're numbers nonetheless. So 1 plus the square root of 5 is approximately 3.24. 1 minus the square root of 5 is approximately negative 1.24. And just to show you real quick, if I wanted to, let me recall this, 2 times x minus 1 squared equals 10. 2 times x minus 1 squared, I'm going to do minus 10. Where are we? There are solutions, which are the two values we just solved for. So graphing does allow us to check our work here. This is a perfect example of why graphing isn't always the best method, because negative 1.23607 is not exactly the right answer. Technically, there are a lot of other decimals that we are rounding off of. So if we were to write x equals negative 1.23607, that would be incorrect. The exact answer we are looking for is x equals 1 plus or minus the square root of 5. So this is how we solve using inverse operations. Essentially, whenever there's an x value, one single x value, we are going to take the square root and use inverse operations to solve. Here's another example for us. Technically, you could try to factor this, but again, I notice that there's only one x value, so my first thought is to use inverse operations. I am going to isolate my variable. I am going to simplify to get x squared equals 20 over 9. Now that's not going to simplify for us, so we're going to leave it the way that it is. And my last step is going to be to take the square root. Now taking the square root of a fraction is going to be challenging for some of us, but essentially what we do is we take the square root of the numerator divided by the square root of the denominator. We don't typically like to have square roots in our denominator, and luckily for us, the square root of 9 is just 3. So we've got the plus and the minus in front. Now the square root of 20 I can do off to the side here. What we want to do is look for a perfect square that multiplies into 20, particularly the biggest possible. And that's going to be the square root of 4. So the square root of 4 is 2, and we can't simplify the square root of 5 anymore, so that stays the same. So our answer here is going to be x equals plus or minus 2 times the square root of 5 divided by 3. Again, if you want to, you can convert that into a decimal approximation and double check with the graph, but this is the exact answer, so we are going to leave it just like this. Now, we've got another problem, that looks like this. We actually can factor this one as well. However, again, the big indicator for me is we've got one, we've got one x value, so I'm going to use inverse operations to solve. So we get x squared equals 25. Last step is square root and square root. I end up with x equals plus or minus 5 as my solutions. One thing I do want to point out is we had a problem like this. So we can solve using inverses and get nice rational numbers such as 5 and negative 5. We can get mixed numbers here like 1, well they're still irrational, but we'll get 1 plus the square root of 5. And then we get numbers that could look like this, where we've got fractions with radicals. It really kind of depends. Now in this situation here, I would go ahead and move my 25 over, and we get x squared equals negative 25. If I take the square root of both sides, we get x equals, well, if you try to take the square root of a negative, you do not get any real solutions. So right now, what we're going to say is no real solutions. If you notice, I said right now, we're going to say no real solutions. A little bit later on, I think in our next unit, we will be able to solve when we take the square root of negative numbers for what we call imaginary solutions. All right, for now, we don't really have to worry about that. It's not something that's going to come up, but if you end up having to take the square root of a negative, your answer will be no real solutions for the time being. Okay? This is how we solve quadratics using inverse operations. Again, the big takeaway is each of these have only one x value in the problem. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.